There's a hidden component deep inside your computer, working tirelessly every single second you use it. You've probably never even heard of it, but trust me, without it, your PC would grind to a halt. Today, we're going to pull back the curtain on this unsung hero of high-speed computing.
Seriously, think about it for a second. How is it possible that you can be downloading a massive game update in the background while you're in the middle of an intense online match without everything just lagging to a crawl? Well, the answer is a really brilliant solution to a huge problem that plagued the very first computers.
So to really get our heads around this, let's imagine your computer's CPU is the brilliant CEO of a company. It's a strategic genius, great at complex thinking. But back in the early days, this CEO had let's call it a major flaw. It insisted on doing all the boring, menial filing work itself.
Yeah, every single time a program needed data from a hard drive or a network card, the CPU had to stop everything it was doing, all that important high-level thinking, just to basically act as a delivery person. It would fetch the data, carry it over to the main memory, and only then could it get back to its real job. And this, as you can imagine, created a massive performance bottleneck.
And you can see just how inefficient this process was. The CPU, which is your most powerful and expensive component, is constantly being pulled away from critical work to do these simple courier tasks. It's kind of like asking a top surgeon to pause an operation just to run down the hall and grab a box of bandages. It is a massive waste of talent and time. Okay, so facing this massive bottleneck, computer architects came up with a genius solution. They didn't try to make the COI file any faster. Nope. Instead, they hired a specialist, an incredibly efficient assistant whose entire job is just to handle these data transfers.
And this assistant is actually a piece of hardware called the DMA Controller, or DMAC for short. The process it manages is called Direct Memory Access, DMA. And just like the name says, it gives devices like your hard drive a direct line, a direct access to your computer's memory, completely bypassing the CPU for all these routine tasks.
And here's the best part. The CEO doesn't have to do any of the heavy lifting anymore. It just delegates. It gives the DMAC a quick little to-do list, where the data is, how much of it to move, and then it just gets right back to work. The DMAC handles all the logistics, communicating directly with the other devices to get the job done. It's beautiful.
But hold on a second. Both the CEO and the assistant need to use the same main hallway, what we call the system bus, to move around. So how does the assistant take over without causing a total traffic jam? Well, it all comes down to a very polite and very, very fast handshake.
The real elegance of this system is just how quick it is. A device needs data, so it signals the DMAC. The DMAC politely asks the CPU, "Hey, can I borrow the bus?" The CPU finishes whatever tiny little instruction it's on, grants permission, and just steps aside. The DMAC then swoops in, handles the entire transfer at super high speed, and immediately hands control back. The CPU is only interrupted for an absolutely minuscule fraction of a second.
Now, this assistant isn't just efficient, it's also incredibly versatile. It actually has a few different strategies for moving these packages around, depending on how big and how urgent the job is. We call these DMA transfer modes.
So the DMAC uses three main strategies. First, you've got burst mode. This is the fastest. It just grabs the bus and moves a whole chunk of data all at once, but the CPU has to wait. Then there's cycle stealing, which is a bit more polite. It moves a tiny bit of data, gives the bus back, and then repeats. It's a little slower, sure, but it keeps the CPU working, which is why it's the most common approach. And finally, demand transfer is a flexible mode that works as long as the device is ready. The whole point is choosing between maximum speed and maximum CPU availability.
Okay, so we've gone through a lot of the technical stuff, but why does any of this really matter to you? Why is this unsung hero so critical? Well, it's because basically every smooth, multitasking experience you have on your computer is a direct result of DMA hard at work. Remember that question from the beginning about gaming while downloading? That's DMA in action. Ever copied a huge folder and your mouse didn't freeze? Yep, also DMA. Streaming a 4K movie without that annoying buffering wheel? You can thank the DMA controller for that, working tirelessly in the background, freeing up your CPU to handle what you're actually focused on. So, the key takeaway here is pretty simple. Specialization works. By offloading the simple but constant task of moving data, DMA lets the CPU focus on what it does best, complex computation. This one change makes the entire system so much more powerful and efficient. It's a total game changer.
DMA was a revolutionary solution, and it's still absolutely essential today. But as things like AI, VR, and machine learning demand just mind-boggling amounts of data,
you have to ask yourself, what comes next? What will the specialist assistant of tomorrow's computers even look like, and how will it reshape our technology all over again?